Today we're going to look at the second part of C2 for the AQA syllabus, which is all about organic chemistry. Now, this is largely split into two sections, but they are heavily related. In the first section, we're going to talk about crude oil and fuels and some other bits of theory related to those two things. And then we're going to talk about organic chemistry in a bit more detail, but we're going to stick purely in this video to the combined science syllabus. I will then pop up a second video which will go into detail about the triple content, because as you'll see, there are quite a few specific triple only topics down here. So let's start with crude oil and fuels. So first of all, what is crude oil? Well, fundamentally, crude oil is a mixture of hydrocarbons. It is a very, very viscous liquid, which means it's thick. And it is found deep underground, and you can see on the screen there an example of a drilling site where they remove it. It is a fossil fuel. It is a finite resource that one day will run out. Now, as it's a mixture, it is not actually all that useful on its own. And in order to use the different parts of crude oil, or fractions as we call them, it undergoes something called fractional distillation. And that's what this diagram here shows you. So fractional distillation is where, very, very simply, we heat up crude oil to around 350 degrees in a large column. As you go higher up in that column, the column gets cooler. And at those different temperatures, different types of hydrocarbon will condense and will then be collected. Now, where they are collected in the tower, whether they're collected down the bottom where it's very warm or at the top where it's far cooler, is entirely down to their boiling point. And their boiling point relates to the size of the chains. So there's some detail here about them. The fractions that we find down the bottom are the ones with the largest chain length. Now, when we refer to chain length, we're talking about the number of carbons in that chain. So they're very, very large molecules, which means they have strong intermolecular forces, not intermolecular bonds. We're talking about forces here. It's important that we use that phrase, intermolecular forces, because bonds refer to the intramolecular bonds. So things like the carbon bonded to the other carbon within the molecule. And those do not get broken when we are evaporating and condensing substances. Now, those are very large molecules, whilst having a very high boiling point, also are not very volatile, which means that they don't evaporate very easily. They also don't flow very easily. They are very viscous, they're very, very thick, and they don't ignite easily. So they aren't very good for things like fuel. And in fact, what they tend to be used for is things like tarmac and roofing. As you move further up the column, your molecules become smaller and smaller, which means they can remain in a gaseous state at lower temperatures. And right at the top, you have your smallest molecules. Some of these do not condense within the tower and are collected as gases themselves. Other substances are collected as liquids and are things that we see and we know of in more detail. So diesel comes down in rather still quite a warm part of the column, and further up you have things like fuel and petrol. And these are mostly different types of fuel, and they're fuels because there are lots of energy stored within those bonds. Now, these are very volatile and therefore very flammable. They ignite very, very easily, and they flow very easily. Those that are in the liquid state have a low viscosity, which means that they are not sort of that thick liquid. Now, that's fractional distillation. That's how we separate these substances into useful substances. And within this, some of them are more useful than others. Now, before we move on to how we use useful fractions of crude oil, let's first of all talk about their use as a fuel. Now, combustion comes up in this module as it comes up frequently in chemistry because it's a really important chemical reaction for you to be aware of. And as most of those fractions are used in one way or another as a fuel, you need to know the two types of combustion. So first of all, combustion is simply burning fuel or burning something. That's what combustion refers to. And for your GCSE, you need to know about two types: complete combustion and incomplete. Now, the difference between these two types is the amount of oxygen that is in your reaction. So if your fuel burns in plenty of oxygen, you will undergo complete combustion, where your product is carbon dioxide. Now, carbon dioxide, as we know, is not a particularly brilliant molecule to be emitting lots of. We know that it is a greenhouse gas and it leads to global warming. However, in terms of its immediate hazard, it has a low risk. It's not toxic to human life, and so therefore it is safer. In incomplete combustion, we burn fuel in less oxygen, and therefore we say that it hasn't been completely combusted, and you make substances such as carbon monoxide, which is a toxic chemical. Carbon monoxide is so toxic because it gets into your blood when you inhale it, and it takes the place of oxygen in hemoglobin. And that means that your body therefore doesn't get the oxygen it needs to do respiration. So it's a very toxic substance. You often will have a carbon monoxide monitor in your home. You also sometimes also do this type of incomplete combustion where you make just carbon on its own, carbon particulates. And you'll notice that when you see sort of soot or smoke coming out of the back of cars, of old cars, I should say, because they shouldn't really be doing this. And that can lead to breathing problems. Carbon particulates can irritate the lungs, and so they can exacerbate things like asthma. Now, in your exam, you also need to be able to balance these. So I would like, please, for you to pause the video, look at the general equations given to you, and rather than just doing any old fuel, I would like you to look at CH4. And CH4 is methane. So that's the fuel you're going to burn. I'd like you to write the equations for the complete and incomplete combustion of methane, and I would like you to balance it. Pause the video now and have a go at that, please. So you should have done that. And you should see that the balanced equation for complete combustion is CH4 plus 2O2 gives you CO2 plus 2H2O. Notice that there are 2 lots of oxygen for every 1 lot of methane. So it's a 1:2 ratio. So there's double the amount of oxygen in terms of molecules than there is methane, and that's plenty. In terms of incomplete combustion, the first one shows us the reaction that provides us with carbon monoxide. And you can see here that the ratio is 2 molecules of methane to 3 molecules of oxygen. And that means that you have a 1 to 1.5 ratio. So less oxygen per fuel molecule, which means you only make CO rather than your CO2. And the last one here, which only is balanced using your 2 for the water. And here you notice that you have a 1-to-1 ratio. So this is even further incomplete because you haven't got enough oxygen even to make carbon monoxide. Now, in the exam, they will most likely want to see this version of the incomplete combustion equation. And they'll always be very clear about whether it's complete or incomplete. There may be a clue in the question. So that's one thing that they might want you to talk about in terms of crude oil. Now, as I mentioned before, there are some molecules that are more useful than others. And actually, the shorter the molecules, the more useful they tend to be. And one of the things that happens in fractional distillation is that whilst you make lots of nice, small, useful molecules, you also make quite a few very large and less useful molecules. And because we want to make use of crude oil as effectively and efficiently as possible, because it is a finite resource, what we want to do is see if we can break down those very large molecules into smaller, more usable ones. We also want to try and make some alkenes. Alkanes are saturated molecules. And we'll talk about this more in a second, they are reactive but are far less reactive than alkenes. Alkenes are used for a variety of different things in industry. They're what we call a feedstock. So actually, we want a process that's going to allow us to do that. And so what we do is we do a process called cracking. Now, there are 2 types of cracking. There's catalytic cracking, where you use a temperature of 550 degrees Celsius and a catalyst called zeolite, but you can just say a catalyst. And that breaks down large molecules into smaller ones. The alternative is steam cracking, which is where you have steam and a higher temperature of 800 degrees Celsius, and that then will also break down those large alkanes. But what is cracking? Well, let's look at it in more detail. So cracking in general is where you take a large alkane and you break it down into a smaller alkane and an alkene. Now, it doesn't always have to be an alkene, but for the purposes of what we're going to do, this is the way it looks. So, for example, if I have hexane, which is a molecule, an alkane, which has 6 carbons in it, and I crack it, I can form butane, that's my alkane, and ethene. Now, what I would like you to do is, if you feel confident, I would like you to try and write the formulas of those compounds for me, and to show that one hexane molecule will in fact break down into a butane and methane. So pause the video now and have a go. If you're not sure, maybe you haven't covered it yet, the formula looks a little bit like this. So hexane is C6H14, and that gets broken down into C4H10, which is your alkane, and C2H4, which is your ethene, is your alkene. And that makes sense because 4 plus 2 gives you 6, which is the carbon, and 10 plus 4 gives you 14, which is your total hydrogens. And that's the big thing with cracking to keep an eye on. These two will always add up to this one, and it's important because that is a really easy 1 or 2 marks to get in the exam. So what I'd like to do now is to pause this video and think about what would go here. I will help you out and tell you that this molecule here is an alkane. So what molecule would this one be here? Pause the video now and have a go. So if this is C10, well then we know that our carbon here must be the leftover from the initial molecule that's being cracked. So it must be C6. And if 22 hydrogens out of the 34 are in this alkane, well then we have 12 left over. I've written that a little large, I made that a bit smaller. We have 12 left over here to make our alkene. And this alkene is called hexene, and I know that that is the correct formula for an alkene, so that all makes sense. That's cracking. Now, there are lots of examples that you could use and that you could do with that. There are plenty of exam questions that do talk to you about cracking, but it basically is cracking a big molecule into smaller ones, and those products are one alkane and one alkene. So that's crude oil. That's pretty much a very short introduction to everything you need to know about it. If you need to pause now and go back over this crude oil section, please do. Alternatively, we're now going to move over to look at organic chemistry in more detail. So we're now going to look at alkanes and alkenes. On the combined syllabus, you only need to have a knowledge of those two organic molecules. However, on the triple syllabus, we talk in more detail about alkenes, alcohols, and carboxylic acids, as well as briefly touching on esters. But we will do that in a separate video because otherwise this video would be very, very long. So let's go on first of all and talk about alkanes. So alkanes are a homologous series, and I like to think of a homologous series as referring to a chemical family. That's what we talk about when we say a homologous series. So alkanes are a family of organic chemicals. Now, alkanes all have the standard formula of CnH2n plus 2. What that basically means is if I have got an alkane that has 3 carbons in there, the way I calculate how many hydrogens it's got is I do 3 times 2, that's your 2n, plus 2. So 3 times 2 is 6, add 2 is 8. And that is propane. Now you need to also understand how to name alkanes. And down the bottom here, you can see these prefixes: meth, eth, prop, and bute. Now these 4 all are your prefixes in your alkane that you need to know. You will not be asked to recall the names of any larger than that. However, they tend to go in the same pattern as the naming of shapes, so it becomes a little easier anyway. Now, meth, eth, prop, and bute relate to the number of carbons. Meth is 1 carbon, eth is 2 carbons, prop is 3 carbons, and bute is 4 carbons. Now, the ane, the ane, that is the suffix. I like to think of it as the surname. All alkanes have that ane bit in their name, and that's how you know they belong to the homologous series of alkanes. So an alkane with 1 carbon would be called methane. An alkane with 2 carbons, ethane. An alkane with 3 carbons, propane. And an alkane with 4 carbons, butane. What I'd like to do now is to pause the video and to write the formulae for each of these 4. The number next to them is how many carbons they've got. So I would like you to use the formula up here and have a go at writing those out. Off you go. So you should have done that. I'm just going to zoom in slightly so I can show you the answers. So methane is CH4. Ethane is C2. 2 times 2 is 4, plus 2 is 6. C3H8, as I went through before. And butane, we have C4H. 4 times 2 is 8, plus 2 is 10. So those are the formulas of the first 4 alkanes that you need to know. Now, a few more pieces of information that we need to know about alkanes. Alkanes, on the whole, tend to be less reactive because they are what we call saturated. And that means that every carbon is making 4 single bonds. This is really important because where there are double bonds, we call a molecule unsaturated. And that means there is a capability of that double bond to be broken and for that molecule to make additional bonds. So that makes it really reactive. So alkanes tend to be less reactive because of that. They have 4 single covalent bonds to other things. Now, let's move on to alkenes. So alkenes are another homologous series. Now, remember, a homologous series is just a family of compounds. And alkenes are alkenes because of their functional group. That's what makes them an alkene, and that is this bit here. They contain a single carbon-carbon double bond. Now, that carbon-carbon double bond can come anywhere in the molecule. When you get to A-level and possibly degree, you'll understand how to name different alkenes depending on where the double bond sits, but that's what makes it an alkene. And because it's got that double bond, and it doesn't have 4 single bonds, it has a double bond and then 2 other bonds, we say that it is an unsaturated molecule. And that means that we can add more things to it. It's not completely bonded. Now up here I've written can form alkenes. That's not what I meant. What I meant to say is that double bond means that it can also form polymers. And alkenes form polymers via something called addition polymerization. And we'll learn about that in a different video. Now, alkenes have a similar naming convention to alkanes. We have eth, prop, and bute. But there's no meth, there's no methene. Can you think about why there might not be any methene? The reason we don't have a methene is because the functional group of an alkene is a carbon-carbon double bond. Meth would only have 1 carbon in it. And you can't have a carbon-carbon double bond when you only have 1 carbon. So the alkenes actually begin with 2 carbons. They are ethene. And that one, like I said, has got 2 carbons. Propene would have 3, and butene would have 4. Now, the formula for alkenes is a little bit different to the formula for alkanes. It's not CnH2n plus 2, it's just CnH2n. And that's because the double bond removes the need for the extra 2 hydrogens. Same as before, if you've got the N given to you by the name of the compound, you can work out how many hydrogens there are. I'd like to pause the video now, and I'd like you to write for me the 3 formulas of those alkenes. See if you can go any higher. Okay, so let's get down the answers then. So ethene would become C2, and then we just double it, H4. Propene would be C3H6, and butene would be C4H8. Now, the other bit of information for the combined syllabus that you will need to know about alkenes is that we can test for alkenes. So alkenes and alkanes, when you see them, when they are soluble, when they are in solution, they're both clear liquids. They're actually a little bit less viscous than water, so you can kind of see they're slightly more runny, which gives you a bit of a clue that they're not water. But you can't tell the difference just visually by looking at an alkene and an alkane. So what we do is we use bromine water as a test. Now, all bromine water is Br2, which is bromine dissolved in water. And what we do is we shake this unknown compound with bromine water. If there is a colour change, if it goes from orange to brown, which is the colour of bromine water, to colourless, which means that the bromine has not disappeared, but is no longer in the form of bromine, it's now part of a compound, then that shows you that you have an unsaturated molecule. It shows you that somewhere within your molecule, there is a carbon-carbon double bond. So it means if I shake an alkane with bromine water, nothing would happen because there's nowhere for that bromine to bond. There's no double bond there. However, if I've got an alkene, such as ethene here, now I'm going to draw you the display formula for ethene so you can see where it fits. Ethene is C, double bond C, and then 2 hydrogens on each one. Remember, carbon is in group 4, so carbon can form 4 bonds. Here it's doing so with a double bond, which is worth 2, and then 2 additional hydrogens. Now, when we react it with bromine water, what that double bond does is it basically opens up to accept a single bond on each of the carbons, and the 2 bromines bond across the double bond like this. Now, this one is simple because it is showing you a compound with only one pair of carbons, if you like. So there's only one place the bromines could be popped across. It would be good to practice drawing the products here with propene and butene, just so that you can see where that would go. Now, on the triple syllabus, there is more information that you will need about these organic molecules, but if you are just studying the combined syllabus, that's all you need to know. So, that is the first section of the the second section of C2, and all you need to know for organic on the combined science syllabus. If you're doing chemistry, which is triple science, sometimes known as single science, an additional video will be up in a little while, which will go into more detail about alcohols, alkenes, carboxylic acids, and esters. Thank you.